Okay, we just talked about global circulations. Now we're going into the mid latitudes where we live. So this is really relating right to all what we're learning about. So what systems shape our weather? Well, remember, we're in the transition zone from the tropics to the south, the Arctic, very cold, dry air to the north. So that means there's going to be a lot of changes in our weather, depending on which direction the wind flows, how these circulations move. So something you've got to understand is there's air masses. We've talked about them at the beginning of the course. We talked about high pressure, literally generating air masses. Why is that? Because the air doesn't move a whole lot in high pressure, so they take on the characteristics of the ground under them. Think about it. If you lived in central Canada, much of the year you have snow on the ground. You don't have a lot of water around there, right? So that air mass is going to tend to be cold. It's going to tend to be dry. Here you go way up north by the Arctic, maybe colder even. Oh yeah, say I form in the northern Pacific Ocean. Well, high pressure there is going to be light winds over relatively cool but still moist air is going to develop, and you're going to wind up with maritime polar. You can have some continental tropical air masses that form literally many times in the southwestern U.S. They also form in other deserts regions of the world. Again, they're tropical in the sense that they're warm, but they're continental in the sense that they're dry. Now we have the maritime tropical ones that form over the Gulf or Atlantic. Think about it. There's that large high pressure at 30 degrees north. Many, many times that high will spawn maritime tropical Atlantic air masses. They're forming over warm, moist water. So now that we know these different air mass types, and remember, these are all in a constant battle in the mid latitudes, trying to have control. So air masses can change with time. Think about it. If you're coming out of Canada and you have bare ground in the United States, what's going to happen to that air mass as it's moving south? Well, that bare ground's heating up, right, from the sun. So it's going to tend to warm the bottom layer. You're going to get convection, and that air mass is going to modify. Bring in a moist air mass from the Gulf of Mexico, and with time, the further north it moves, it's going to tend to modify. So these air masses change when they get away from the source region. That's why in the wintertime, for example, you may get a Canadian air mass coming into Ohio. By the time it gets to me a day or two later, I may be 10 to 15 degrees warmer than what you are getting because you're closer to the source region. The same holds. I may be more moist and more humid and hotter in the summertime when a big old high pressure forms over the Atlantic and tends to pull in the moist air off the Atlantic into my area. By the time it reaches you, it has modified. It still may be hot, but maybe I might be a little bit warmer, but you might not be nearly as moist. So you can see how the air mass modification takes place with time. And tropical air masses do tend to modify less with time. So the boundary of an air mass is a front. If that boundary isn't moving, it's stationary, simple. And that boundary is going to have a slope. Cold air is on one side of that boundary, warm air is on the other. And remember, anytime that the warm air is trying to move north or cold air trying to move south, the warm air is always going to tend to rise over the cold air. It's less dense. So that's why you see the clouds stretching over the colder air, and with the most of the rain near the frontal boundary. A warm front, just warm air moving north. You may actually have precipitation starting as snow or something, but the warm air begins to move north and change over to rain as it's pushing closer and closer to the frontal boundary. Clouds might start as cirrus and gradually lower to stratus clouds. Cold air, on the other hand, remember, cold air is much more dense, so it's moving. It tends to have a very steep slope at the front of it, like a cliff almost. So it's going to, warm air that it's pushing out of the way is going to tend to go up more vertically. It's going to take more thunderstorms. And cold fronts can move in all different directions. This is a typical backdoor cold front. I personally hate them because I don't like having air coming in off the Atlantic, the North Atlantic, into my house, because what it does, it brings all the moisture from the North Atlantic into the low levels. I wind up with a lot of clouds, fairly cool. And I do not like cloudy, drizzly, cold days. Occluded fronts. What happens when a strong low pressure system develops? You have the cold front moving east and you have a warm front along it. Eventually, that cold front begins to overtake the warm front. And when it does, an occlusion forms. What happens is the warm air that was behind that warm front has gotten pushed aloft, and you have the cold front and the cooler air ahead of the warm front merging. And that's where the occlusion occurs. A warm occlusion just means that the air moving in from along the front to the west typically is not as cold as the air that's being pushed out of the way. A cold occlusion, the cold air coming in from the west is actually colder than the cool air ahead of the warm front. And here you can see that there's extratropical cyclones form. They form all over the place all the time. Matter of fact, in the wintertime, there's typically 2 or 3 across the United States at one time. We talk about the last chapter, how you need a short wave in the atmosphere with a strong jet to cause divergence. What happens, that divergence begins to create a low pressure. Remember, the strong jet is going to be where the temperature contrast is the greatest. So that low pressure is going to form along a front, and we typically then have counterclockwise circulation around the low, northwest winds pushing the cold air down, southwest winds pushing the warm air north. Here's your circulation, the beginning of a extratropical low. With time, the cold air is getting pushed down further, and we get more and more intense low. Oh yeah, eventually you get this occluded front, where the cold air from the west has pushed in and pushed out the cold air to the east, the warm air to the east, and made an occlusion. The last phase of most extratropical cyclones is the occluded phase, and that's when they reach their most intense point, and they begin to weaken after that. And here you can see the incipient low moving, cyclone developing, comet head forms, the occlusion forms. There's another way of looking at that. That was a Norwegian cyclone model. Another way of looking at it is look at conveyor belts. All right, this can get a little bit more complicated, so follow me here a little bit. What happens at the low levels? You have a low pressure. It looks like it's just off of Cape Hatteras. All that warm, moist air is being pulled north. And it's being pulled north ahead of the cold front. So it's being lifted as it's moving north. When it does that, it lifts over top of this cool air to the north. There's probably some kind of maritime or Canadian high pressure, continental polar high pressure, even up here to the north. This warm air is lifting over top of that. It's causing clouds and precipitation to fall. Now, under that, high pressure rotates clockwise, so that moves that air back to the west. This cold conveyor is being lifted as it's being pulled into the low, because the air is rising in the low pressure. It's being lifted up, and above it, there's a strong jet stream. So what happens? It pulls it back to the northeast. So that's where you get your comet heads from, that cold conveyor belt. Dry air comes in behind it, drying everything out as the low is moving away. So that dry air is sinking behind the low, pulling in drier, warming the air. That sinking motion does, so you wind up getting clearing skies. Sometimes they move almost into the center of the low. That is part of trying to forecast how much rain you're going to get, or snow, how fast that dry air can get to you. And you can see all the different weather types along the low pressure system. And one of the neat tricks is if you can get a good barometer and look at low pressures, Where they're falling fastest, that's where the low's moving towards. Where they're rising fastest, that's where the low moved from. So you can actually track low pressures. And I've used it sometimes to realize that in my forecast, I was moving the road the wrong way. It may not be a lot of distance, but I can use that to modify my forecast and make a better forecast for you. And here you can see all various low tracks. You're going to get an Alberta low. They tend to stay up to the north. They can be fairly strong, but they're very cold. A lot of snow, light snowfalls with them because they have no source of moisture. They move across the Great Lakes. They have the Great Lakes moisture, but that's not a lot. Now, Colorado lows, which come down further south, pull in the moisture from the Gulf of Mexico. What happens is you get lots of moisture with them, lots of heavier rain or snow. And then along the East Coast, well, we get nor'easters that come up and develop off the Atlantic coast on the triple points. We get nor'easters that develop in the Gulf of Mexico, other storms in from Texas, and you can get them too coming off up through Texas and maybe even coming a little bit west of the mountains. Depending on where you are in the sector of a low, depends on the type of precipitation in the wintertime. If a low moves to your east, you're always in the colder air, you may get more snow. If the low moves to your west, you're tending to get into the warmer air, you may get more rain, maybe even some freezing rain. And once the low is north of you, maybe you have a cold front that's going to go through. One of the other things about extratropical lows, these are cold core lows. What does that mean? Well, cold core, the air is more dense, pressure is going to drop faster in the vertical, you wind up with lower pressure further aloft. The most intense part of an extratropical cyclone is the air is aloft, not at the surface necessarily. Weak ones still, you'll see them cool, but they'll tend to be a slope back to the west. Warm core lows, they happen in the summertime many times out in the desert southwest. What happens? The ground heats, gets extremely hot, the air begins to rise and forms low pressure near the surface. But remember, as it is rising, that air is beginning to cool, but it's less dense, so it's not cool, not lowering the pressure as fast as it goes up. You actually wind up with ridges of high pressure, usually an anticyclone. So cold core get more intense with height, warm core weaken with height. Tropical cyclones like Fred, that's out there right now, or Grace, are warm core systems. They actually lose intensity as you go along. There are anticyclones, as we've talked about. Because they sit over an area with weak winds, they're very stable. They create an air mass. There are other circulations out there. There are sea breezes. Lake Erie has a classic one. If you go to Lake Erie in the spring and the air, big high pressure sitting over you, warming the land up, the air is going to begin to blow off of Lake Erie, and it is going to get cooler very quickly because Lake Erie is probably 20 to 30 degrees colder than the actual land where you are. I used to live on Long Island. We would get these in the early part of June, and you could literally see them coming in off the ocean because they would bring a fog or a mist in. And literally, as they moved in, it got cool, it got foggier. It was not a pleasant day at the beach. Valley breezes and mountain breezes. There are just opposite circulations caused by the mountain. Think about it. During the daytime, the sun is heating up the slopes on the mountain very well. Air is going to rise up the slopes. The middle of the valley is going to tend to be cooler, pushing the air down. Nighttime is just the opposite. You have the air cooling along the mountain slope. The winds are going to move down into the valley and rise, be pushed up because they're coming down into the valley from both sides. So the air will rise in the middle of the valley at night. That's all it is. And these are extremely useful if you're dealing with wildfires that occur on mountains. They're used all the time to predict the direction and motion of that wildfire. Chinook winds are winds that come down off of a mountain. They can really, really warm it up. Believe it or not, there are actually some Chinook winds in the eastern United States Not as powerful as the ones in the western U.S. where the mountains are taller, but down off the Appalachians, sometimes the west wind will clear things out over the eastern part of the United States, of our area, and warm them. Now, in the west, Chinook winds coming down can change temperatures from 0 degrees to plus 50 degrees in a matter of minutes as they pass. And they also occur in the Santa Ana area as well. Hababs, a dust storm. They're generated by very strong winds coming down from a thunderstorm that hit the ground and blow up dust. Typically, they're dry, and all that dust is moving along, making pretty miserable conditions. Heat burst. It's a thunderstorm where there is no rain at the bottom of it because the air is so dry that the air is being pushed down and warmed as it's sinking, and literally can raise temperatures from 70 to 80 to over 100 degrees in a matter of minutes. So these are the atmospheric circulations that are out there, and just taking a quick peek at them right now, you can see high pressure over the northern part of the eastern United States. This high developed over Canada. It's a continental polar air mass. Not exactly cold now, this time of year. To the east, see this high pressure here? It's a maritime tropical air mass. Cold front right here is a contrast between these two air masses. Here you can see it stationary out in the Rockies. Guess what? The Rocky Mountains influence this. They actually block it from going west sometimes. They can cause stationary fronts there. And when the flow aloft is not that strong, it doesn't really go too far. So let's just take a look a little bit at satellite. I wanted to just look at it quickly. Sometimes on satellite you can actually see the warm clouds developing a little bit over top of you. And we know we had a cold front in the one part of the area here. Well, guess what? That warm, moist air is being lifted and causing clouds to the north of it. To the south of it, there's all kind of convection because we have moist tropical air coming in. And if you were to look over here, just zooming into the northeast section, and I have a reason for wanting to be interested in this because we're forecasting thunderstorms near my house right now. So I want to know if there's a lot of convection developing there. And south of me there is, and I can see some right in here. And here's a couple bubbles of convection developing. So there is beginning to be some along that cold front. That boundary is pushing air upwards. So as you can see from all of this, we have all this fun stuff. Mid-latitude is a great place to live and to have changing weather. So any questions, please don't hesitate to ask.